Let's discuss the continuity at two different points of a function. This is the function given to us, and it says that we have to discuss the continuity at x is equal to 2 and x is equal to negative 2. So let's first do x is equal to 2, right? So at x is equal to 2, the actual value of the function is f of 2. And as you can see, when x is greater than or equal to 2, this also includes equal to 2, by the way. Since we have to see x is equal to 2, the value of f of 2 is equal to this 3, right? Now let's discuss the left-hand limits and the right-hand limit. Remember, the rule is that continuity exists only if the right-hand limit is equal to the left-hand limit, right? So the limit as f of x approaches 2 from the left-hand side is basically the limit of x squared minus 1 as x approaches 2. Why is it this particular one? Well, because when x is less than 2, the value of the function is x squared minus 1, which is why we've taken this one, x squared minus 1. So now that you input the limit 2, you get 3. So far, so good, because that's what we have here. And now let's see the right-hand limit. Now, for the right-hand limit, you'll use this 3 again. Why? Because when x is greater than 2, the value of the function is 3. And the right-hand limit approaches from above 2, the value of x above 2. So you take 3. And so, since 3 is a constant, you cannot apply this limit, and 3 will remain as it is. So it is equal to 3. Now you can see that the left-hand limit is equal to the right-hand limit. And so the limit of f of x as x approaches 2 exists, and that was equal to 3. Remember? And so the function is continuous at x is equal to 2. Fairly simple. Now let's do x is equal to negative 2. Now, you can see that at x is equal to 2, the value of the function, what is it? X is equal to negative 2. The value of the function is equal to 3x. Why? Because x is less than or equal to minus 2 over here. And when x is less than or equal to negative 2, you have 3x as the function. Since it includes the equal to part, you'll use 3x. So 3 into negative 2, that is negative 6. So f of negative 2 is equal to negative 6. Now, let's see the left-hand limit, right? So the left-hand limit, how do you find it? Well, when you approach x from the left-hand side of negative 2, you'll use this 3x again, because when x is less than negative 2, you have 3x as the function. So any value below negative 2, negative 3, negative 4, negative 5, anything that's approaching from the left of negative 2. So that means 3 into negative 2, you get negative 6. So far, so good, right? Now let's see the right-hand limit. Now for the right-hand limit, that means you have to go above negative 2. When x is greater than negative 2, you'll use x squared minus 1. Now instead of x squared, you'll input negative 2. So negative 2 whole squared minus 1. And that is equal to 3. Now in this case, the left-hand limit, which is negative 6, is not equal to the right-hand limit, which is 3. Since negative 6 is not equal to negative 3, the limit as f of x approaches negative 2 does not exist, right? And that's because so f of negative 2 is not equal to the limit of f of x as x approaches negative 2, right? Because it's discontinuous. It does not approach the same value as from the left-hand side and the right-hand side both. It only approaches the value from the left-hand side. It does not approach the value of negative 6 from the right-hand side. So the function is discontinuous at x is equal to 2. I hope that helped.